Okay, so next up is Alexandra DeLucia talking about decoding strategies for interactive narrative generation. It's a really cool talk about a system that can create stories. Okay, I'm just going to turn your mic on and mine off, and you can begin.
Okay, so hi, I'm Alexandra. Today I'll be presenting decoding strategies for interactive narrative generation. This work was done in collaboration with Aaron Mueller, Lisa Lee, and Zhao Sedok from Johns Hopkins University. I wanted to start off with a quick introduction. I'm a PhD student under Mark Dredzy in the Center for Language and Speech Processing at Hopkins. My primary research is doing civil unrest detection and forecasting event with Twitter data. And my secondary newfound research is messing with chatbots. So to make sure we're on the same page, I just want to define interactive narrative generation. So this is similar to response generation, where a user provides a prompt and expects a relevant response. However, with narrative generation, the response is long and should contain some kind of a plot. Our motivation for this work is because neural response generation and narrative generation are so similar, we aim to bridge the gap between them. Specifically, we wish to explore the effect of common decoding strategies from neural response generation on narrative generation. Okay, now for some background. I will briefly discuss decoding for text generation, the concept of diverse decoding, and then briefly mention a few relevant narrative generation models. So decoding is the language modeling portion for text generation. The decoding step determines how the next token in a sequence is selected. There are search-based and sampling-based decoding methods, but for this work, we're only going to focus on sampling methods. There are a few common ones, such as top K sampling, where you only use, out of all possible tokens, you resample from only the top K. And then there's nucleus sampling, also known as top P, where it's a similar idea. You resample from a smaller distribution, but only using the tokens that make up the top P of the cumulative distribution. And then there's random sampling, which can be thought of as a special case of top K and nucleus sampling, where you sample from the entire distribution, where in this case, it would be as if K were equal to the number of tokens and P equal to 1 for nucleus sampling. And another special case, greedy sampling, also known as argmax, where it would be equal to K equals 1 or P equals 0, where you only take the top token and you don't look at any other options. So there is a common issue in neural response generation, that the model often returns a generic or boring response. This is dubbed the "I don't know" problem after one of the common phrases. This issue is due to generic responses having a high probability in the language model because they are common in the data set, and many are acceptable responses in many situations. The examples below are sure, I'm sorry, great, and nothing. These can easily fit in many prompts, but they are not interesting, and we want our bots to be much more interesting. There are many options to combat this "I don't know" problem, but for this work, we focus only on one solution. Lee et al. Came up with a decoding objective function to discourage these high probability generic responses. This is called the MMI anti-LM, or anti-language model objective, and it works by decreasing the bias of the language model and encourages choosing tokens that are more specific to the context. The effect of this objective is controlled by this weight parameter lambda. So now to discuss a few other narrative generation models. The ones most relevant to ours is the Fusion model, developed by a group at Facebook, and a fine-tuned GPT-2 model from a group at Stanford. The Fusion model is an ensemble of 2 seek-to-seek models that were trained on a set of creative writing prompts and responses from the subreddit r/writing prompts. In that work, they used top K decoding with K equals 40. The fine-tuned GPT-2 model from Stanford followed the Fusion model in that they fine-tuned on the same data. And instead of only using, formed a top K parameter sweep. So in our work, we also fine-tune a GPT-2 model on writing prompts, but we perform a nucleus sampling parameter sweep and add in a diverse decoding objective parameter sweep. In our full work, we also add in other axes of analysis like model size, but for this presentation, we will focus only on one model, GPT-2 medium, and only the parameter sweep for nucleus sampling and diverse decoding. So to answer our research questions, we will fine-tune GPT-2 for narrative generation, perform a decoder parameter sweep for nucleus sampling and diverse decoding, and then evaluate our model with respect to diversity and quality. To fine-tune GPT-2 for narrative generation, we use the same writing prompts data set used to train the other narrative models. Writing prompts is a collection of prompts and responses from the creative writing subreddit community. As input, we use the standard start and end tokens and 2 new special tokens to identify the prompt and response. These are WP and response tokens, respectively. So the writing prompts dataset contains a variety of response links. So we create 3 different size data sets, but for this presentation, I will only discuss results from the medium length data set, which consists of all the prompts, but the responses are all truncated to the second line break. These different size data sets were used for other axes of experimentation that I will not be discussing today. For the decoding parameter sweep, we use a discrete set of p-values for nucleus sampling and lambda values for the MMI anti-LM diverse decoding. For p equals 0, that's p equals 0 and p equals 1 are included for completeness, since p equals 0 is equivalent to greedy search and p equals 1 is equivalent to full random sampling. And as for the lambda values, we include lambda equals 0, but that just represents we are not using diverse decoding. Looking at previous work, we expect p-values around 0.9 to perform the best and expect the model to become more degenerate as lambda increases, since it will be paying less and less attention to its own language model. So the goal is to measure the effect of decoding parameters on narrative diversity. According to Tevitt and Barant, there are 2 types of diversity: diversity of content, or what to say, and diversity of form, or how to say it. They found that scentbert is best to measure content diversity, and a distinct N is best to measure form diversity. So as everyone in the field knows, automatic evaluation can only do so much. Humans are not obsolete yet. Since we are generating stories, we want our stories to be interesting, fun to read, fluent, it's a story written in grammatical English, coherent, do all the sentences form an understandable plot, and relevant. Does this generated story actually follow the prompt. Fortunately, our human evals are still in progress on Mechanical Turk, so any qualitative observations that I make in this presentation are just from me and my co-authors. So I just wanted to start right off by showing some examples. As Abby had mentioned before, GPT-3 is a thing. This is using GPT-2 Medium. And GPT-2 is still pretty good, not on this slide right here, because these are the lower p-values. But for this example, we can see that greedy search is obviously very degenerate. It's very repetitive. And for p equals 0.3, it's still repetitive, a little better. Some of these examples are going to be long, so I'm not going to spend too much time on each slide. Don't worry about rushing through reading them. These slides will be posted where you can read through them at your leisure. But that greedy search one, just imagine that, just say it in like Navi's voice in your head, and then it becomes a lot better or worse, depending on your opinion of how annoying Navi is. And then as we move up to increase our nucleus sampling parameter, it gets better. So these are good. They seem to be pretty fluent. They're like kind of interesting. Okay. For p equals 0.9, this one where it starts getting a little wild. For some reason, like the purge is in here. Kind of interesting. There's more action going on. And finally, for p equals 1, also very interesting. We got heart implants, lots of pain. Our model seems to be a little on the dark side. But yeah, and there are a lot more examples elsewhere that I will discuss how to access them later. So this was just for the nucleus sampling sweep. Those were examples with some of my qualitative comments. For the automatic evaluation, where we said distinct N measures the form diversity and CentBERT would be used to measure the content diversity, we see that as our p value increases, that diversity increases for both form and content according to these automatic evals. But while we were reading the responses, we also see that this does not completely capture what was fully going on. So even though p equals p equals 1 is more diverse according to the automatic evaluation, p equals 0.9 was also very good, and p equals 0.7 was also good. So it seems that these automatic evaluation for diversity can only be used as a guideline to maybe pick out the ones that are obviously very bad or degenerate, such as greedy. But other than that, we're still going to need to mostly depend on human evaluation. So that was for the nucleus sampling parameter sweep. Now for the diverse decoding sweep, we held our nucleus sampling decoding at p equals 0.9 because after looking at other examples, we agreed that we like that one the best. These ones are a little short. So again, lambda equals 0 is equivalent to not using any diverse decoding. And then lambda equals 0.2 is using a little bit of diverse decoding, but you're still paying attention to your language model. And lambda 0.8 is you're ignoring a lot of your language model, but that made it very interesting. It seemed that GPT-2 has a powerful enough language model that it could take a hit for ignoring it that much and get some really interesting things like leaving babies inside of black vacuum boxes. Um, so definitely interesting things coming out of GPT-2 with this diverse decoding. This is just some automatic evaluations of the diverse decoding suite with regards to different p-values for nucleus sampling. As we can see, so distinct N, again, was to measure form diversity. This increases as p-value for nucleus sampling increases. And according to the automatic evals, once you raise lambda over about 0.2, there doesn't seem to be that much of a gain until you get to 0.8, and then it starts going downhill, which could be due to a sign of degeneracy. So in summary, we fine-tuned GPT-2 Medium for narrative generation with prompts and responses from the subreddit r/writing prompts. We performed a parameter sweep for nucleus sampling and diverse decoding to experiment with new neural response generation methods applied to narrative generation methods, and we evaluated the diversity of the output with distinct N and CentVert. And for our findings, we found that nucleus sampling p-values between 0.7 and 0.9 appeared the best, with the lower values tending to go towards degeneracy. This might change as we roll out our full human eval survey on Mechanical Turk. And also we found that the diverse decoding hyperparameter lambda is directly correlated with response diversity according to the plots, the automatic evaluations, which is cool. And there is definitely a trade-off between diversity and coherence, which is due to the paying less attention to the language model as you increase the diversity. So I just want to say thank you for your time, and I would like to plug our bot. We turned it into a Reddit bot, and I had to create our own subreddit for it because r/writing prompts does not like it when you post automatically generated content on their subreddit. I got banned the hard way. So there is a bot narrative generation community on Reddit. Look it up, just r/storygenai, and our bot is Storybot AI, and it goes through every day and posts responses to the top 10 writing prompts from r/writing prompts. And we're still trying to come up with ideas on what to do with our data set of generated stories that just keeps growing and growing every day. But yeah, so that's it. I guess I can take some questions now.
Cool. That was an awesome talk, Alexandra. Really good job. So I have a question. Hold on, let me just take the slideshow down so we could have a conversation. Oh, that's so weird because that's not me. So I'm wondering, like, you have a great way to generate these stories, but the stories might not be that coherent, and the plot might not really flow all the way through. And I'm wondering if you think that you could combine this approach with approaches from the computational models of narrative community, where people are writing things that can evaluate like how coherent a plot is, or like what the motifs in a story are, something that like can analyze like the types of events in a story. So I'm wondering if you think that this kind of approach can be made even more coherent or more interesting or more human by using approaches of narrative understanding.
Yeah, definitely. I mean, I'd have to say probably the first thing to do is, I don't know, just shove it through GPT-3, right? I think if you put in something, it'll just output the next Game of Thrones or whatever. But for, yeah, borrowing methods from that community would definitely be very helpful and very cool. The immediate thing I was thinking of was a paper that was at ACL a couple weeks ago, where instead of generating word by word, they were using a model that had an extra model that ranked next possible sentences. So it would be really interesting to use something like this to create maybe 50 tokens at a time to create a couple different possible continuations, and then have an external model that's trained for coherence that ranks those responses. And then it just kind of feeds back through that. That was an interesting paper out of ACL. But yeah, no, definitely borrowing from more standard community of like motifs and everything would definitely be a good approach too.
Sorry. And I'm even thinking maybe on the training end for like the stories that you're training like the language model with, you could even feed in some information about the narratives that you're training. Like, these are the motifs that are in the stories. This is like which tokens like represent which aspects of narrative. I think that could also help too. So like not just on the checking at like verifying whether GPT like is producing coherent stuff, but also like on the kind of as like a pre-processing or feature generation side for the learning, so that the things that you're learning on are also more structured. Like, you know that this sentence represents this aspect of narrative. Like, this is a climax, and this sentence is a denouncement, and this sentence has this kind of relationship to some other part of narrative. I think that's something that I would do, maybe.
Yeah, no, that definitely sounds really cool. I'd love to talk to you about it after.
Cool. Let me go to YouTube. There's no questions on YouTube right now. I want to see if there's any questions in our Zoom room. Does Dea or Josh or Abby, do either of you have a question?
Yeah, I had a quick question. So sorry if you already went over this during your presentation, but so you mentioned that you were measuring or representing both the form and the content diversity. So how was it that you were being able to extract those from text? I'm just curious, like, I know there's like neural style transfer in computer vision, but I'm not too familiar with all the literature for NLP.
Yeah, so this was just from some work by Tevitt and Grant. This is footnote 1 on the current slide that's up, where all they did in their work was they were looking for all the common evaluation metrics that are already used for text generation evaluation on like quality and diversity, and they were just seeing which ones actually correlated with diversity. So they compared different methods, different metrics to human evaluations. So in this case, diversity of content, they're mostly just picking up on more semantic meaning, where they're using sentence BERT to create a representation of a narrative, and they see how different it is from another narrative just by using cosine distance. So that's what this automatic evaluation of diversity of content is. And then for diversity of form, this is the distinct N metric, which is a token count based method for unigram. Usually it's just unigrams and bigrams. And all this does is check and see if your model is just using the same words over and over again. Yeah, so this is very much just like an automatic based evaluation.
Cool, thanks. It was a great presentation, by the way.
Thank you.
Awesome. Hold on. Awesome. So thank you for your talk. I'm just going to do a clap.